Good morning. Can y'all hear me clearly?
Yep.
Perfect.
I
I'm just checking. We have 15 participants. Let's go ahead and get started. Cool. We finished Module 2 last time. As mentioned, and maybe you recall, there were a couple additional problems that were in Module 2 that I simply skipped over, and I said these were just more practice problems. You have enough to do in Replit, and so there was no need to, due to our time constraints, to cover those just additional problems. But for those who are interested and are wanting to practice more, I highly encourage you to feel free, go back to Module 2, the PDF, which is online, and to practice through those. What we have today is Module 3, which we're going to cover quickly. A lot of this has already been covered. There's no new major topic within Module 3. From the textbook that I used, that I made these slides from several years ago, the author simply put some extraneous additional small details within this particular chapter. It was chapter 3 of the textbook. And but I'm definitely looking forward to on next week on Tuesday and then Thursday, because that's when we're going to cover the first major construct, if you will, of Python, where we learn about selections, which is if, else, and even nested if and else statements. And once we get to that, we can start to make meaningful, or at least more meaningful, programs. But today it's just covering some small things, practicing some additional problems, talking about the replets, and let's jump right in. So first, the idea of a function. That's going to be on Module 6 is when we're going to actually make our own functions. But for now, we introduce what is the concept of a function. A function is a group of statements. Okay, I want to make sure I am sharing my screen, right? A function is a collection or a group of statements that are put together for the purpose of accomplishing some task. And in fact, we have used functions since day one. The very first function all of you learned about is this right here, the print function. What does that print function do? If within Thani, if you type print and then you put parentheses, and inside those parentheses you put, let's just say, a string of text, and you say, hi, my name is Bob. What does that do? The print function takes what's ever inside this set of parentheses, and it displays it to your screen. So under the hood, if you were to look, like we say, under the hood of a car, under the hood of a vehicle, you know, there's the way the engine works. You don't need to know all those details. You just want to drive the car. Well, under the hood, all you see is this is a print function. But if you lift up the hood and you look inside, how that works, there's more to it than that, of how it ultimately just displays this information on your screen. So there's several lines of code to make that happen, but we don't need to know about that line of code. We just need to know what the print function does. What does it do? It simply displays information to our screen. We also learned about the input function, right? We learned about input. We learned about the int function. We learned about the eval function, which evaluates anything within those parentheses, right? These are all kinds of functions that we have learned about. Int. What does int do? Int takes whatever is inside the parentheses, such as 4.8, if that were inside the parentheses, and it erases the decimal and everything to the right of the decimal. It just deletes it. So if you were to say x equals 4.8, and then if you were to print x, the result is you would be printing 4. So you're effectively deleting the 0.8. That's the int function, okay? We also have the float function. which simply takes a given number and converts it into or understands it as a floating point number. So we looked at many basic functions, but you haven't explicitly heard the word function until now. So this is a list of several functions that you have seen, okay? So I'm gonna comment this. Here are several functions, and you may notice I made a new Python program called Module 3 Notes, and I encourage you to do the same. So we want to keep the notes for each module within a different program. So I called this Module 3 Notes. So here are several functions which we have already seen. So with that in mind, looking at these functions, and I'm going to comment out very quickly, how can you take a guess? How can you tell that something is a function versus something is not a function? Looking at that list of functions, what would be your guess? Anyone, quickly.
Parentheses at the end?
Absolutely, Charles. The parentheses at the end, okay? The parentheses at the end show you that those are in fact functions, okay? So anytime you see something and parentheses, then you know that that is a function. Okay, so if you were to see blah, parentheses, well, guess what? That would be a function. This would mean that blah is a function. Okay, so we've learned several functions. And there are two classes of functions, if you will, that we can categorize them into. The first is those functions that we define, that we create ourselves, which we'll do in Module 6. And then there are those functions that are part of the language that are already created for us to use. So I want to show you, here are some additional functions. And these functions are already built into the language. They're not the most exciting, but they're already built in, and that we have access to them and we can use them. We can use them directly. So if I wanted to say, how about min or max? If I wanted to say x equals min of 18, 7, and then print x, it's going to automatically calculate for us the minimum of those two numbers, which is just 7. And in fact, according to this description, we can come enter multiple numbers in here. 21, 19, 100, 2, 18,764, and run that. Very cool. That gives us the minimum of those set of numbers. What about y equals, and let's take all of this and paste it, and let's change that to max. And then print our y. We get the maximum number. So those are two functions that are built in. I think you already know ABS, absolute value, how that would work. So how about z equals the ABS of -8, and then print z. We would expect that it's going to print 8. Okay, and by the way, so here I'm just printing the value, but just so I can try to help y'all get into good habits, let's start from here on out always, no matter what, even if we're printing just a single value, so we can develop good habits, let's use formatted printing. So how would I do that? Brackets, dot format, x. And if I'm going to be honest, it's obviously overkill to use formatted printing just to print a single value, but why not? Just so we can get more comfortable with formatted printing. And what makes it easy is that now with that done, I can just say x colon, right? Y colon. I can actually just print the variable in a colon and a space beforehand to make it look a little prettier. Okay. Let's see. Round. I'm not going to talk about rounding, as I mentioned, because rounding in Python is horrible. And I left it to all of you to go read about why it's horrible. Additional math functions. So these functions are available to us by default. Print, eval, float, min, max, ABS, round. There are additional math functions. If I were to type SQRT, all of you can likely guess what that stands for, square root. Okay, many of you in high school, depending if you've taken trigonometry, you could likely guess what this stands for. Okay, sine, cosine, and tangent. And this is not a math class. We're not going to learn trigonometry, and we're not here to teach you math. Just want to share with you that these functions are included as part of Python with a specific condition. So by default, if you were to type these functions, they work automatically. But if you were to type in such as square root, if I wanted to say, how about answer equals SQRT of 100. Now we know that the square root of 100 is 10. But when we run our code right now, it's going to give us an error. It says, and I know these errors look cryptic at first, but they're not. If you just try to read it slowly, it highlights it in blue. Okay, so I'm going to click down here where it says line 21. I click, and notice it highlights that line for me. It highlights it up here. Watch. I click line 21, and it says there's an error on that line, and it gives us the line answer equals square root of 100. It says name error. The name SQRT is not defined. Okay, so it doesn't understand square root, even though I'm telling you it's part of Python. And the reason why is that although it's part of Python, this function square root is included in the math library. So let me first comment these two lines out. So I'm going to put a comment here. Those two lines above are currently commented out. Why? Because as of this moment of typing this line, we have not included the math library into this program. Therefore, those two lines will cause an error. So all of these functions that are sine, cosine, trigonometric functions, square root, and additional functions, those are built into Python, but they're specifically tucked away into what we call a library. A library, in this case, the math library, it's a set of functionalities, a set of functions that are available to you, but you have to effectively go to that library, import it into your program, and specifically instruct Python that, hey, you want to use that library. Okay. So how do we use the math library? Simple. We import it. Okay. So let's do that now. Go type import math at the very top of this program. So scroll all the way up before everything on line 1 and type import math. Okay. And now I'm going to take those 2 lines of code that I had commented out, and I'm going to paste them below, and I'm going to uncomment them, and it's going to work just fine. In theory, no, because I need to type math.square root. In theory, it will work just fine. So even though we imported math, we still have to type math.sqrt. And so once that's done, we can now take the square root of a number. I can change this to any other number and take the square root of it. Again, not the most exciting. And hey, can someone tell me very quickly, how do I get, let's just say, only 2 digits after the decimal right here? Uncomment and tell me, what do I type to get 2 digits after the decimal? When I print my answer.
Wouldn't it be round?
Nope, right here within these curly brackets. We did that last time. Yep.
:2f.
Colon 0.2f. And now it prints it with 2 digits. And that's the purpose of using formatted printing, that we can very quickly, I can make it 5 digits after the decimal, right? But if I don't put anything here, it'll print it. And we covered this at the end of last session. but we have all those digits, which are unnecessary. So when I put 0.5f as an example, here's our answer with 5 digits after the decimal. So always try to get in the habit of using formatted printing. So I'm going to very quickly just skip over some of these slides because I'm not here to teach you math. And even if I wanted to include it, like even when I teach this at the college level, we don't sit there and go over these in detail because many students don't remember their trig. I don't care if you know what the sine of pi over 2 is, and it's crazy, but I actually remember that even though I don't teach math. If once you know your sine function, you should know, what the sine of pi is. You should know the curve. Nevertheless, that's not something that we need to focus on. So here was a problem that was introduced, and solve it, and to go find something with the sides of a triangle. I'm not going to even cover that here, and I gloss over it because we don't need to. We don't need to confuse you with math. The purpose and the takeaway is just for you to understand that if you had a problem that required you to use harder math functions, those functions are in fact available to you. Also, what's nice is we were previously calculating the area of a circle, and we were having to manually type in the value of pi as a constant. We were saying pi is 3.14159, blah, blah, blah. Well, in fact, pi, once we import the math module, pi is available to us. So check this out. I'm going to actually print, oops, I'm going to, oh my goodness. Let's try that again. I'm going to highlight this, comment pi, or I'm saying the constant pi is available to us in the math library. And so I can just print pi, and I'll type here math.pi, because I have to actually type math dot to access the things in that library. And so now, it doesn't have, it does. How do I access pi? Is it lowercase? Yeah, it's lowercase. Boo. Bad programming, Python. There are things I respectfully disagree with Python, and I don't like that it's making that lowercase because it's a constant, and constants are supposed to be by default uppercase. Nevertheless, there's math.py. Okay, so here what I like that you can see, and which is why I like to program in front of students, is like even when I program in front of college students. When I was teaching many years ago at UCF in front of 300 students, I'll get to your question, Mohan, in a second. I was happy to code in front of them. And a lot of professors did not like to because they were nervous if they make mistakes. And I was like, look, we're humans. We're going to make mistakes. I like students to watch me make mistakes, and then they can see how I debug it, and to give you confidence that everyone makes mistakes. If you have Windows, you should be very familiar with the fact that programmers make mistakes, because your Windows can crash and can freeze. Mistakes are common, but it's important to just recognize that everyone's going to make mistakes, but how do we debug them? So just now that had an error. I don't use math.py, so I had to go back and figure out what was my error, and it was just the fact that it was called lowercase pi. Okay, and I had to very quickly look that up because I don't memorize it, and no one really memorizes those things. So this is one small library, the math library. There are hundreds, thousands, when you look at Java, of libraries. Nobody memorizes those libraries. No one. What you do is when you need something in a library for your school right now, you go to the library. You go to Wikipedia. You look it up, right? You don't memorize the encyclopedia. You don't memorize everything at the library. You go access it when you need it. You try to figure out what you need and you use it. Mohan, go ahead, unmute, and do you have a question?
What do you write in the brackets in the formatted form?
Yeah, so well, here's just an example you can see on my screen. I'm not going to recover that today. That was covered last session. And even if you were here, maybe you just missed it because it was quick. So after we're done today, I'll encourage you to go to the YouTube channel and watch Tuesday's session, part 2, and the end of part 2 from last session, where we specifically cover what you put inside these brackets to be able to do the different things. Is that fair?
I looked for the video on Tuesday, but it wasn't on YouTube. I couldn't find it.
Ah, well then I'll make sure it is, but maybe I have it hidden at the moment. So I will make sure it's available after the session.
Okay, thank
You're welcome. Okay, let's see here. So I'm gonna very quickly, I skipped over that. So the whole goal here was I want you to know that those functions are available to us. Let's see, don't need to cover that. So here for the student, actually let me cover one more page. We've already covered strings, but I'm gonna do this again. And again, anything I'm typing here, I don't do this because I like to type. I do this because I want y'all to type this. So you should try to keep up, but as always, if you can't keep up, if I'm typing too fast, make sure afterwards you go watch the session on YouTube so you can type what was missed. So strings verse single characters, okay? So in many languages, there is a clear distinction between a string of text, so a grouping of 0 or more characters, and a single character, okay? For example, in Java, C, C++, all the C's, C#, the distinction is very clear. So if we wanted to make a string, we would enclose that string of text in double quotations as follows. So I would say some string equals, this is a string, okay? And if we wanted to make a single character, we would enclose that single character in a set of single quotations as follows. Some character equals W, for example, okay? So the difference between a string and a character is simply whether it's double quotations versus single quotations. Mohan, do you still have a question? If not, you can take your hand down. It's okay. So the difference between a string and a single character would be double quotations versus single quotation marks. You have a question, Mohan? You have to just hit it once if you don't have a question. There you go. Now you have no hand up. That said, this is very important. That said, in Python, there is no such distinction between characters and there's no such distinction between characters and strings. There is no such distinction. So whether you have a string or a character, you can use double quotes or single quotes, it doesn't matter. Let me get rid of that said, because I want to type it now. In Python, there is no such distinction between characters and strings. That said, we want to learn universal habits, or maybe I should say, or programming good practices. Thus, my recommendation, even for Python, make strings in double quotes and single characters in single quotes. That's a lot of typing, but I can't slow down. So some of you have that, great. Some of you type fast, great. Some of you type slow, no issue. You'll be able to type faster as you get practice. But just go back to, I know you understand that was a lot of typing for something so simplistic. Just make sure if you want to type that all up, you go back to the video afterwards. So that's what I wanted to cover on strings versus quotes. I'm sorry, strings versus characters. Either one in Python. Here's a single string. Here's a single character A. We can put it in double quotes or single quotes. It doesn't make a difference in Python. But as I mentioned, the recommendation, let's use double quotes for strings, single quotes for characters. So if and when you ever learn another language, you aren't confused and you transition very smoothly. For those who are interested, page 15 all the way to page, let's see, all the way to page 26. I'm going to skip. I put that here. I was tempted to delete it out of the module when I made these modules because I made them from the slides that I use at the college level. And I was tempted to delete it, but I figured some students may be interested. It's important to recognize and to understand ultimately that a computer, as we covered on day one, as we're typing all this code and we're making Python programs and we're solving replets, and when you're on YouTube and watching videos, it's important to recognize that a computer, in the end, it only understands ones and zeros, or even more specifically, it's not ones and zeros. We depict it as ones and zeros, but a computer only understands electrical signals on and off. That's it. Computers are not intelligent. They only understand electrical signals. A high signal, meaning on, a low signal, meaning off. So with that in mind, how does a computer differentiate between an 8 and a 4? Or a 15? Well, this 8 is understood as a certain set of electrical signals. This 4 is understood as a certain set of electrical signals, as is this 15. Every keyboard character, A, B, C, D, those are all individually understood as a different set of electrical signals, which is crazy, but that's how it works. And so for the interested participant, you can go read. We're going to skip over this page. Notice it says a brief hiatus, where we briefly leave the discussion. We talk about we talk about binary numbers. We talk about how those binary numbers map into the characters that we are using, the alphabetical characters we're using. We talk about ASCII and Unicode, all kinds of stuff, which is extremely helpful, but it's not as important for due to the time constraints that we have for this boot camp. So for those who are interested, you can go reference page 15 to 26. So here's a question for you. If I wanted you to code this lineup right now, and I know some of you already know the answer, so don't just shout it out, and I appreciate you not just raising your hand immediately and shouting it out. If I wanted you to code that lineup, meaning, like, if you read in a textbook, if you're reading in just a book for your own, leisure reading, whenever you're quoting someone and you're saying like, hey, someone said such and such, you put that inside quotations, right? So if you wanted to actually print this line of text as is, meaning, so you want to say, he said John's program is easy to read, because therefore you want to actually print a quotation, right? You want to print this quotation here, and you want to print this quotation here because you're quoting someone. This is going to cause a problem. If we print this exact line as is, it would give us an error. I want you to brainstorm, and I can think of several students in here who already know the answer because they've studied this before. So don't shout it out if you know the answer, please. But someone else raise your mic, and you maybe are guessing the answer. So if you're truly guessing the answer, feel free to guess, and that's good. Tell me why you think this line of code would cause an error. Go ahead, Mohan.
Maybe because there's two different sets of quotation marks, and it
That
won't
is-
be able to process how.
That's exactly correct, because what is the first, so when you're in a print statement and you see, so here's the print statement, it's a function, and remember, within the function, we're going to have a set of quotations. So here's the word print right here, this fantastic keyboard typing. And when Python sees a quotation, Python says to itself, ah, the user's about to give us a string of text. And Python keeps reading that string of text until it sees a second quotation, which it matches up with the first one. And it knows that between those two quotations is a string of text. And then after that second closing quotation right here, Python's expecting other stuff. Maybe it's expecting a plus sign, which we haven't studied. That's how you can concatenate, which is to glue together multiple things. Or Python might be expecting something else. But it would not expect just more characters. If you have just basic keyboard characters, those need to go inside a string of text. So what happens is when Python is examining this statement, it's going to see this quotation. So it says to itself, aha, what follows must be a string of text. And Python goes all the way till here, and it sees a second quotation. And so now it says, okay, so now the programmer's done with that string of text, but then it sees a J. And it's like, what is this J here? That doesn't make sense. You messed up. So that's going to give you an error. Okay? That will in fact give you an error. So how do we make that happen? How do we actually print a backslash? I'm sorry, how do we print a quotation mark? So if we don't want Python to understand, because clearly we don't want Python to understand that quotation as the end of the string. In fact, our string is starting here, and clearly we can tell as programmers that we're wanting the string to end there. So we don't want this to be the end of the string, nor do we want this to be the end of the string. So how do we tell Python to not interpret this right here as the end of the string, but instead just to print it? What we do is we put this backslash right before the quotation mark. And that backslash is a special character that tells Python, hey, pay attention. We don't want to just end the string. We want to do something special. Okay? So here, if I say print hello, and then I put a backslash, and then I put a quotation, in fact, that's going to be an error because Python is not going to see this single quotation as ending the string. Because what happens is when we put a backslash, because I want you to understand how this works, that Python is going to go character by character. Python's going to see, okay, here you're printing a string because it's the first double quotation it sees. And then it sees an H, so it prints the H. It sees the E, so it prints the E. It sees the L, so it prints the L to the screen. It sees the next L and the next O, so it prints those to the screen. Then Python sees a backslash, and Python says, whoa, the programmer put a backslash here. That means that the next character we have to treat differently than a regular character. So if you put another quotation right here, double quotation, Python's not going to treat that the way it normally would. It's going to say, the programmer wants to actually print the quotation. Cool, we'll just print that to the keyboard. And then if you put another double quotation, when Python, I said to the keyboard, to the screen, when Python sees this quotation, it will then end the string. So here, we printed hello with a single quotation afterwards. What if I wanted to put the whole thing in quotations? I would do this, hello. So this idea of putting a backslash to make Python take pause and recognize that the next character after a backslash is important, that is called escape characters. Escape characters, okay? What are escape characters? They are special characters used inside, very important, used inside strings of text. Okay? these special characters tell Python to do special things. In this case, so here, if backslash single quote, okay, that backslash followed by single quote tells Python to print a, by double quote, tells Python to print a single double quotation mark. Okay, that's just one example. So here are all of the different escape characters. We're not going to use many of them, but so if you wanted to tell Python to print a double quotation mark, you put backslash double quotation mark. If you want to tell Python to print a single quotation mark, you put a single backslash single quotation mark. What if you want to tell Python to actually print a new line? This is cool and something you're actually going to use. You will actually use this one a lot. Out of all of these right here, there's really only one that you end up using a lot, and that is backslash n. So if you check this out, I know it's going to be weird at first, but if we say print, hi, my name is Bob. All of that got printed. Each individual word got printed on a different line. Why? Because I put this backslash n, backslash n, backslash n, backslash n, and backslash n. Anytime you put a backslash n, I can put 3 of them right here all of a sudden. There's 3 back to back to back. It puts 3 lines between them. So backslash n is very common because before you learn that, anytime you want to print just a blank line, students do this. If you wanted to print two blank lines, you have to do that. There's 2 blank lines. Okay. Now, if you want to print a blank line, you just put backslash n. That's important and worth commenting. So how do we print a blank line of text to the output? Prior to today, we must type the following like that. Now we can just type backslash n inside part of our string. We have a minute and a half left, and this session is going to end on see if there's a question. So this is a good time to stop. Ibrahim, you had raised your hand.
Yeah, so in the slides, one of the escape characters was backslash F, and it said form feed. What did that do?
We'll cover that later. We'll cover that later. Okay. And then finally, what if for some reason you wanted to actually print a backslash? Hypothetically, what if I wanted to print a backslash? Because we know that backslash is a signal to Python that the next character is important. So if you want to just print a backslash, well, you can't just do that because that backslash is a signal that the next character should be treated differently. So how do you print a backslash? You just put 2 of them back to back. The first backslash says, hey, the next character is important. And the second backslash right afterwards says, no, it's not. I just want to print a backslash. Okay, that's a lot of details. It's not the most exciting. We're going to get to a problem coming up after this next session and after we stop this one. So here we go. Let's end this gracefully, and I'll post the link for the next session.